What's up, biotech enthusiasts? In today's episode, I will be sharing one of my very own ideas on an application of CRISPR-Cas9. So, if you haven't watched the CRISPR-Cas9 episode yet, make sure you do, since this episode builds up on topics covered in the previous one. Now, let me introduce you to my one for all generational CRISPR vaccine. Now, imagine this. What if we never had to take multiple vaccines for multiple infections, and our children would never have to take one of those vaccines as they would be born immune to these diseases? Well, that's what my idea addresses. Both unimaginable concepts, that is, before the discovery of CRISPR. Let's dive into my idea, shall we? So, the possibility of my idea lies in advancing human technology and accepting the ethical changes CRISPR will bring to society. Now, my idea is based on incorporating the E. coli bacteria's entire immune system within the human cell. Yep, you heard it right. I basically just said that we should become bacteria. On a more serious note, though, we have reached the point where this kind of incorporation of a bacterial immune system will be possible in the next few years. Since having a vast library of the sequences of pathogens will lead to an enormous DNA segment, fitting this CRISPR sequence within a regular drug delivery particle, such as a lipid nanoparticle, will be painfully hard. So, we must instead use specialized drug delivery systems such as the adenovirus drug delivery, which can hold at most 38 kilobytes of genetic material. However, one base pair occupies 0.33 kilobytes of data, and the average spacer size is 35 base pairs. Okay, so the biggest step, or the only step in the entire process, is incorporating the CRISPR sequence and the Cas9 enzyme within human cells. Now, this can be done easily using CRISPR Cas9. By adding an intron included CRISPR sequence for various infections to the end of the cell's DNA, we avoid changing the frame of the DNA as well as allowing it to be expressed in a smooth manner by alternative splicing. Now, if this step is successful, we basically have created a full database of various infections within our body that can be used to identify and fight off any of these infections. Thus, the name One for All, one vaccine for all infections. But that's not all. There's also another connotation to One for All, with a small modification in the administering process. Okay, but before I explain that, I need to talk about a simple concept. There are two types of cells, germ cells and somatic cells. Somatic cells are all the cells except the sex cells, or also known as the germ cells. Now, germ cells are the cells that are passed on to the offspring and from which the offspring's somatic cells are born. Now, if we added this CRISPR database vaccine within the germ cells of an individual, not only are we giving them one vaccine for multiple diseases, but we will also be immunizing the individual's children as they would be born with the DNA for CRISPR and Cas9. So, one for all also implies one vaccine for all generations. We will most definitely face a lot of issues and obstacles while achieving this goal. One of these issues would be the drug delivery method. Since having a vast library of the sequences of pathogens will lead to an enormous DNA segment, fitting this CRISPR sequence within a regular drug delivery particle, such as a lipid nanoparticle, will be painfully hard. So, we must instead use specialized drug delivery systems such as the adenovirus drug delivery, which can hold at most 38 kilobytes of genetic material. However, one base pair occupies 0.33 kilobytes of data, and the average spacer size is 35 base pairs. The CRISPR segment itself, with the repeated sequences, would be on average 35 base pairs as well. So, considering the data, we would get a sequence of about 23.1 kilobytes that can fit within the adenovirus capsule. However, we must keep in mind that these are just average values, and we may have sequences much longer that may not fit in the adenovirus capsule. This is just one of the many setbacks we would face in our journey to make this idea into reality. As an example, another issue could be considering if mutations may occur in the CRISPR sequence within the human cell. Now, Make sure you remember that this is all just a theory from my end. We, as a society, have to come to a mutual decision on the extent of limiting CRISPR Cas9. Only after that can we take the steps to make this idea possible. Okay, guys, that's it for today. Hopefully, you guys enjoyed my idea and learned something from it. This is Biotech Breakdown signing out.